Do you got my best side? Oh, well, a guy can dream. Yeah. So we're good? All right. Well, good afternoon, everybody. I appreciate everybody that came out for a late Sunday talk. I really wanted to come up here and support CircleCityCon, but I was out of the country last week, and the soonest I could get here was last night. So we're doing this on a Sunday, and this is going to be called Your Password Policy Still Sucks. The reason it's called Still Sucks, as we were just talking about, was that I did a talk about this about 5 years ago. Hundreds of pen tests later, I still see the same problems in every organization that I still see before. So what we're going to talk about is a little bit about policies and like why current password policies aren't really working, and then we're going to go over some basic, well, maybe not so basic, use of OCL Hashcat. So I get tons of questions in email every day about how to use it. The syntax of it is kind of hard for some of the more advanced attacks, so we're going to go over that. What we're going to do is, I totally revamped this on the plane ride over because of all the dumps that just happened. I'm getting ahead of myself. I'll get to that in a second. So, anybody that knows me, these are my education and certifications that I have. I do have a few credentials, even though I don't have any education or certifications. So I work for TrustedSec. I do mostly red team type penetration testing, black box. I like to know as little as possible about the target, do a little bit of everything. I'm also a member of Team Hashcat. We compete in the DEF CON Crack Me If You Can contest every year. It's put on by CoreLogic. If you're into that and you are keeping score, you will know that there's been 5 contests and we've won 3 of them and come in second place on 2 of them. And the other 2 winners those other 2 years were the Ruskies, the Inside Pro team. So anyway, they're not doing the contest this year, so that's kind of sad. But on the flip side, that means that we won because we won 3 and they only won 2. So that's good too. I also have a little security conference that I founded with a couple other people, Adrian over here and Dave Kennedy. It's called DerbyCon. It's in Louisville, Kentucky. So if anybody's into really having a good time here and you never heard of DerbyCon, feel free to come 100 miles south and go to DerbyCon. And I love cracking passwords. It's my hobby. I don't know what it is about it. There's something super sexy about watching crack passwords rolling through the screen. We're going to see that. You can decide whether you think it's sexy or I'm just an idiot. So, a lot of this is kind of rehashed. I'm just going to go over it really quick, but what's wrong with passwords? They're a single method of authentication. A lot of the places that I'm pen testing are getting a little bit better on the domain, but what's really bad is web applications. Web applications, there's no standardization. A lot of companies don't have any kind of SDLC built into their application building process, and so there's no security. They use weak hashing algorithms and that type of stuff. And so, what we've noticed lately is you'll may have noticed on the internets or the Twitters that there's been several dumps from back in 2012, 2013 that have been leaked recently. LinkedIn, MySpace, Tumblr. I got them on some other slide. There was one other one or whatever, but the thing about those dumps is that type of information is super, super valuable to penetration testers, and I'm going to show you why in a little bit later. And so the other thing that's wrong with passwords is that humans are super predictable. We always say, you hear all those adages like humans are the weakest link in security and all that kind of stuff. I don't necessarily subscribe to a lot of that stuff because I'm more of the mind that, it's the IT securities department to secure the organization rather than the users really worry about security. Some user education is awesome, but if I hire you for IT security, I'm hiring you to protect my organization and to protect the users from themselves with technical controls. So, anybody that knows me knows I'm super into technical controls. The other thing is about 5-6 years ago, GPU password cracking got really big. The rigs these days are getting ridiculously big, and for the amount of money that you can spend on one, it's absurd. And I'll show you what we're working with, But the thing is that lots of people have these rigs. They've become affordable. Like, you know, you got people that are mining Bitcoins and making money, and they can crack passwords on the side. So even using passwords in general as a single method of authentication is basically outdated. However, it's clear that we're not getting rid of passwords anytime soon. What I'm going to talk about is how to improve your policy and your password auditing so that you can at least have some stronger methods of authentication. So basically, like, imagine if every time a company was breached, there were evil hackers and they were gathering and storing all these leaked passwords. Who reuses passwords? Don't lie. See, that was over half the people. The other 50% were lying, but that's cool. Doesn't matter. So everybody's reused a password somewhere, right? And by reuse, I don't mean a different number at the end of it, right? If your Windows domain password is password 1 and your LinkedIn password is password 2, that's reusing your password. Same difference. So basically, every time one of these dumps hits the internet, it's really valuable to penetration testers, and the reason is because I can't tell you time and time again that I've cracked a password in an organization, and somebody was just talking about this earlier at a talk where I went to where, you know, the dude used the same password for his domain admin account as he did for his LinkedIn account, or, you know, because he was like, well, that's work related, I should use my work password, right, or whatever. So, and is it really that guy's fault? Probably not, because he probably didn't know any better. And so the thing is that every one of these breaches, when we gather them, it makes pen testing easier. And so getting these data dumps is really valuable for penetration testers because even though they came from websites on the internet, they've been reused in an organization. I guarantee it. So this is what we do. You know, a lot of people do it for fun, like me. I'm really into breaches, and I like to get the breaches and analyze them and figure out what the most common passwords are. So we're going to look at some of that. But you can believe that the, you know, bad or evil hackers or black hats or threat actors or whatever they call them, you know, whatever the buzzword is this week to call, you know, those people, they're doing this too, right? They're keeping databases of all these passwords like all over the place, and they're getting them off because the majority of users for these sites that are getting hacked are you know, Americans with Gmails and that kind of thing. Like, you know, my friends at CoreLogic just did a analysis on the LinkedIn dump. Like, so a lot of us have been cracking it, and we'll talk about that in a second. But, you know, there was like 3,200 .gov, you know, email addresses in there, which is a lot, you know. And so what are the chances that those .gov email addresses work on some other .gov site that work on some other .gov site? So this is just an example of something those evil hackers might be using. This is actually the web application that we use for the DEF CON Crack Me If You Can contest. I just threw a picture of it up here. I don't know if you can totally see it, but I just want you to see how serious some people are about this. So like if you want to read here, you can see that this is a web application that we use. We have a team of people that, you know, gets together and cracks lists. And so every time a dump comes out, you know, this is a little bit older, so we got eHarmony and DreamHack and a couple others. You know, I recycled this picture from a few years ago, Gawker. And so what happens is every time a breach comes out, we grab it, we upload it, we put the type of hash that it is, we have how many that are found, we have an uploader, so everybody on the team can upload. We have how many are left, so you can download the left list or the found list in plain text. We have total, how many we've cracked. This is how you can download the dictionary as a list. Here's the analysis button that runs a bunch of scripts and tells you what, you know, what the masks are. We'll talk about those in a second. And then here's how you upload to the list. Here's how you make comments for the other crackers. So like, this is pretty serious, right? Like, so people are doing, I know I'm not the only one, you know, that's doing this or whatever. So I get all the time we have a password policy. Who has a password policy at their company? All right, cool. We're going to talk about that. Does everybody know what their password policy is? Excellent. So this can actually help attackers. So this is actually worse sometimes to have a policy. So who has ever gone to a website and you try to put in your password and it gives you some stuff like this, right? This is not, you know, like your password doesn't fit our policy or whatever. So like, I really got this off the internet. I'm not going to totally bust on the site because it's totally absurd. However, this is just an example, right? So let's check this out. Your password may be a combination of 6 to 10 letters and numbers. So 10. Let's all let that sink in. 10. Okay, so it's case sensitive. That's good. It can't contain any special characters. Bummer. It can't contain your username. Well, that's good. So what this tells me is the dude is smart enough to code it so that it can't use your username, but he's not smart enough to use special characters in his application and escape them properly. So that's super. It can't, this is the best one. It can't contain two separated numbers. Example, you can't have 1, 2 with 2 letters in between and then 3, 4. So that would be invalid because this number sequence has been separated. That's pretty awesome. And then it can't contain company name, I'm protecting the innocent here, or password, right? So, awesome. So I really did see that on the internet. Here's all the things that are wrong with that. 10 character maximum, that's pretty bad, right? So, no special characters. The reason that that's weird, and here's some numbers. So the US keyboard has 94 typable characters. If you remove 32 of the special ones, that actually removes 1/3 of the possible character set. So you dramatically reduce the time that it might take to crack these passwords. And then this whole numbers can't be separated thing, I can't get over that. I'm not even sure what that was all about, but anyway. So here's some examples of passwords that we can make with that policy, right? So this is probably the most common. Does anybody know why this would be the most common password? Yeah. So, because humans are predictable, right? So if I tell you that your password has to contain an uppercase character, say if I took 10 people in this room and said your password had an uppercase character, not you guys, because you guys are smart, you're at a security conference. However, they're going to capitalize the first letter, right? Because in the English language, what do we capitalize? The first letter, right? That's what we've been doing all of our lives. We've been writing sentences and capitalizing the first letter. So 9 times out of 10, the first letter is going to be capitalized. Then I'm going to have some string, some, my name, some meaningful word. The word doesn't really matter. What matters is the fact that it's a string, right? I'm starting with a string. Then I'm going to have some kind of date at the end of it because I got to use numbers. And then here's another one. Here's another one. Here's the best possible password I could come up with based on that policy. Right? Does anybody think this is a good password? I mean, be honest. It looks pretty complex, right? Still a word, right? And it's still only 10 characters. And we'll talk about GPU speed in a minute. And so here's some of the stuff that I just talked about on the policy. I'm going to try to burn ahead a little bit because I got some demo stuff I want to try to crunch through. So here's another policy. Your password must be at least 8 characters. It must contain at least 1 uppercase, 1 number, 1 special character. Does anybody recognize that? That's the default Windows Active Directory policy, right? Who's got Active Directory at their work? Who's using the default policy? Liars. That's all right, though. I would say most of the places I go are still using the default Windows policy. Do you have a question?
Yeah, I just have one comment on the no special characters. Every place I run into that, and it's always incompatibility. Like if they have long applications using OID are some special characters, you can actually see the check and password field.
Mm-hmm.
So the quick security for that is just sorry you have special characters. Because if you use 4 special characters for OID, you have 2 left.
No. And so I totally agree, and I do know that there's some situations where it's just not possible to escape special characters properly in a SQL sequence or something like that. But if that was the case, I would not tailor the rest of my policy to say 10 characters only, right? I would have something much more ridiculous to go with it. Or I would try to work a little bit harder to make that happen, maybe find a different application, that kind of thing. But you're absolutely right. I do know that there are some situations where escaping those special characters is impossible.
They do allow special characters, but they only allow 2 of them, and you can only choose 1 of them.
So, probably. I mean, there are some situations, right, in environments where some special stuff has to be made, but that's kind of where I'm going with this, is that there's some other ways that we can police passwords, basically. Yes. Absolutely not. Does anybody remember RockU? The best password cracking list of all time. I mean, it's still the best one. Yes.
For clarification, Oracle OID does not do clear text, but it's directory. So the directory parses what you handed. So you can SQL inject your directory service. It's horrible.
All right. So the Windows policy is a little bit better than that crappy web application policy we looked at, right? But it's still flawed for these exact same reasons, right? Because the thing is that no matter what complexity rules we put in place, the user has to remember their password somehow, right? I don't know a lot of organizations that are actually using password managers. There's a lot of personal ones that are really cool. The enterprise market on password managers is not really taken off like I thought it would. And so basically, like, people are still, no, it doesn't matter how long you say the password has to be or whatever, it's still gotta be something that they can remember. Because, they're just now not sticky noting it to the bottom of their keyboard, right, 20 years later. So we're just getting to where people are actually remembering them. But once again, even with the default Windows Active Directory policy, like, this password is good, right? Martin, 2016, bang. Right? That passes, right? Would that pass in your environment? Awesome. And so you're sitting there thinking, like, my passwords are weak, you'll never get them. And that may be true. I mean, you might have some ridiculous password. But keep in mind that we're talking about average people. This is all stuff that I've, learned on penetration tests. And the thing is that, like, when I go into an organization, like, keep in mind you might have 3,000 users. I only got to get one. And then after that, it's clear text city out of memory, So we're talking about, protecting that first password that I got from, MBNS spoofing, or I, got from Tomcat or whatever, right? The other thing that I found is generally people aren't interested in security until they get hacked. And that's especially the case with web applications. So here's a couple of the reasons that I've seen, that bad password policies continue to happen. Usually it's lazy network admins. They're not doing their, maybe lazy was the wrong term. I should maybe get rid of that. But, like, they're doing the bare minimum, right? Oh, Windows says this is good. That's my favorite, right? This is Windows policy. They said it's good, so it's good. No user education behind passwords. Remember, I said I was a big fan of technical controls, but that doesn't mean that user education doesn't help, right? If you can educate 100 people and reach 30% of them, I mean, that's still something, right? Amanda was talking about it earlier in her talk, is that you're never going to get everybody on board, but they are the first line of defense, right? So there is some reasons to have user education and talk about how to make a good password. Badly coded applications, we already talked about those. CEOs complain. That just goes for any C-level people. Like, I was at a law office one time, and the IT staff, they were really frustrated because they had this some crappy password policy, and they were like, every time we try to up this, the CEO comes down with his new iPad or something, and he's like, this is bullshit. I'm not typing out this password every time I got to get online and stuff like that. So that happens a lot. A lot of times, there's been some talk lately about whether password rotations are good or bad. I can see both sides of the argument. I was just talking about that with somebody before the talk. There's a lot of people that say now that you should just get one, like, extremely long, ridiculous password and keep it, and that rotating them is, making people make predictable and easier to remember passwords. I can see both sides of the argument. I'm not really sure where I'm at with that. Companies not auditing their passwords, I just do not see a lot of this. So, and what I mean by this is as simple as dumping your Active Directory database, having like a predefined set of rules and criteria that you run across that, and then it's like kind of a pass-fail thing, right? These people, failed and these people passed. And I'm not talking about like a punitive thing, but just, sending those people whose password was compromised within like, 24 hours or whatever, like an email that says like, hey, your last pass, yes. Mm-hmm.
So that we know that the person may have lost the company.
Sure.
Because we had a problem where security wouldn't tell us who's on that.
And then you don't remove their account, and it just sits there.
So we couldn't remove their account.
Yep. Absolutely. And that's definitely like important. But what I'm talking about is people, remember my Martin 2016 bang password that passed the policy? I guess I'm talking about auditing passwords like that, right? So doing an audit and sending me an email that's like, hey Martin, you're a really valuable member of the company. We really like you, but your password last quarter was stupid. If you could just step it up a little bit, that'd be awesome, right? So I'm sure there's some like PC way to put that. But anyway, and even like I've even seen, and I've helped institute this type of thing in a couple of companies where, we automate this entire process. It can all be automated, right? And then on top of that, you can get the people whose password was not recovered during the test something that they win. Like, so for example, the one time that we instituted this really correctly, what happened was everybody whose password failed got an email that said, your password sucked or whatever. I mean, they had some cool HR way to say it. But then the people that passed were entered in a drawing for like a $25 Starbucks gift card or something, right? So everybody that passed got, in a drawing. And so that seemed to work really well for this organization. I don't know if it'll work everywhere, but I have noticed that any kind of security stuff that's actually like rewarding rather than punitive works better every time. People like to be rewarded and not penalized. The last thing is that like, when it comes to websites, I mean, like there's, most sites are trying to make money. That's the, primary goal of doing stuff. So sometimes they're afraid if they make their sign up process too difficult or there's too hard to go through or something, you'll go to another vendor and then they won't make money, right? And so they would rather take a gamble on a breach with having a crappy password policy than actually protecting their users. And unfortunately, that's just the way that it is. And I've seen that quite a bit. So leveraging this info. Who does pen testing in here? Well, that's enough people to make this valuable. So most of my talks tailor around pen testing since that's what I do. But so I want to show is how getting this breach data is actually valuable on a penetration test. Because, let's revisit this, people tend to use the same or similar passwords across all internet accounts, right? So I got one chart here that I like to show, and so we're going to talk a little bit about Hashcat and how to utilize that. Does anyone use John the Ripper here, where you basically just like go John word list and it does some kind of kung fu like Star Wars magic, and then some passwords pop out, right? So that's basically called a brute force. Now there is some, John has like, they've incorporated a bunch of Markov chain rules and stuff in there, but basically like, it's kind of stupid, right? It does the work for you. You get some easy passwords or whatever, but it can take a while. And so if you look at the numbers here, say you had a 7-character password, so there's 94 printable characters on the US keyboard, right? So if you put all this together, the amount of time to brute force this at 250,000 passwords per second would be 72 minutes, right? 72 seconds, I'm sorry. But what if you could tailor your attack, right? So say that you knew what the password policy was at the organization. You knew that it was Windows, it was 8 characters, it started, and the policy was capital letter, special, number, or whatever, right? Remember those passwords that I showed you? So we could narrow this down, right? So if we knew that the first number was an uppercase character, we could cut that down to 26 instead of 94, right? So we've already dramatically decreased our cracking time. So if we did upper, lower, 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 digit, special, there's our pattern, right? That we know that, this is only 7, but let's say 7-character policy, whatever. So you can now see that I've dramatically reduced my cracking time because I built my attack based on a pattern rather than just dumping the word list into John and crossing my fingers. So that's what we're going to do. Oh, I feel like this slide should have been at the beginning, but whatever. So these are the breaches that recently came out. They're still valuable, even though most of them came from 2012. Basically what happened is some hackers tried to sell these, and I don't think they actually sold them, or I don't know, whatever happened. But LinkedIn is what we're going to look at today. It's probably the most valuable as far as I'm concerned. Most of these Twitter passwords appear to have come from Russia and that kind of thing. But so in the LinkedIn dump, there's 177 million records, so it's pretty big. So obviously we're not going to be able to crack all that during this hour-long talk, but I'll show you what we did. So there's a lot of password cracking tools out there. I happen to be in love with Hashcat. It's by by far the best one out there. And has anybody used it in here? Okay. So some of this might be boring, some of it might not be, but we're going to try to blow through the easy parts because I don't actually have that much time. Let's see how much time we got. I'm doing pretty good. All right. So this is the server that we're going to be working with. I'm going to SSH to it, but just in case you want to check out what a big GPU server looks like, we have 8 Titan X cards in there. They're actually, we used to build them ourselves, but my buddy Jeremiah's got a new company. I'm going to give him a shout out called Sagata. They build high performance computing servers. They do a really good job. They have some custom firmware and custom bootloaders. They put a lot of work into it, and they're really affordable. I know a bunch of pen test companies have these, so if you're interested in this kind of thing, tell your boss you want to buy one. They're awesome. All right, so the cool thing about Hashcat is it has a number of different attack modes. And so we're going to go through some of these first ones kind of quick because I want to get to some cool stuff. The first one is a dictionary attack. So we just talked about that with John. Basically, you got a bunch of word lists. You throw your hash into the thing. It goes word by word down there, and it checks if it's in there, right? So that's pretty boring, and it's also a waste of disk space, right? You have to have these 20, 30, 40, 50 gig word lists, and then you have to have all these drives. And so that was how it was in the old days with John, but that's not really necessary anymore. The reason is, but I'm going to show everybody how to do, well, I'll get back to that. So we'll get back to that. The next type of attack is a brute force. This, once again, is fairly stupid. You start at A, and then you go to Z. Now, Hashcat's brute force is significantly slower than John's, and the reason is because John's is pre-coded with a bunch of different algorithms and permutations. Like, Hashcat's literally starts at A and goes to Z. So if you're looking for a brute force type of attack, unless you know exactly what character set you're going after, John can be a little bit more effective at brute forcing, except for in this situation that I'm getting ready to show you. So this is the last thing I want to go over, and then we'll do some demo stuff. So this is the part that nobody understands about Hashcat. I don't understand why. But so basically what they do is they have masks, which is like a variable. If anybody does any coding, basically what we're doing is substituting a variable for each character set here. So when we talk about a mask, we're talking about these numbers here at the bottom. And then so, we have upper, lower, digit special, right? Makes sense? Everybody remembers coding in high school or whatever. So anyway, so as long as you understand this mask philosophy, Hashcat is really easy. These are just the character sets that we already went over. The only one I never use, hex is in there for like extreme situations, but it's really not that necessary. The one that everybody always wants to know about is the -A, so that combines everything together. But real quick, there's one other way that you can do it, is you can do custom character sets, where you can assign the different variables, and then so you can do your own character set. So like, for example, if you wanted to do company name and 4 digits at the end, you can assign that to a 2, and so instead of using a question mark A, you would use question mark 2, and it would use that character set. So here's one more example just to drive the masks in. So basically, like, here's a mask of a character policy, and then if they're in green, like, the password would match that mask. If they're in red, the passwords would not match that mask. So I don't know. I'm better at seeing stuff visually. All right, cool. Let me see what the next. Oh yeah, we're not there yet. Okay, so what I've done here. Seriously? What happened to my internet? Of course, this isn't going to work. Oh, maybe Dave didn't pay the bill. Damn it, Dave. All right, so, well, I had all this set up ready to go, so I apologize. But, all right, so what I've done is if you take a look at the LinkedIn breach, and no, I'm not going to give it out, but, So like, let's look at the top of it. So they're all SHA-1 hashes, right? But basically what was in there was user ID, email address, and then the SHA-1 hash. I just didn't want to put somebody's stuff up on the screen or whatever. But so anybody that knows anything about algorithms, SHA-1 is a really insecure hashing algorithm, but it's really big for websites. There's still a lot of websites that store their stuff in SHA-1. Obviously at this point, I'm assuming LinkedIn is promising that they're using a better algorithm or whatever. What's interesting is that if you are a web application coder and you follow the OWASP, they actually recommend scrypt as the strongest password hashing algorithm that you can use, and the amount of times that I've seen scrypt in a web application are like one, maybe like ever. So that's always interesting that, you know, that people do that. So, real quick, hold on. So what I did for the purposes of this demo is I randomly grabbed 650,000 hashes out of this LinkedIn list. So if you count the LinkedIn list, it's going to be, there was like 177,000 records. Once you get all the dupes out, there's like 160 million. I'm sorry, 177 million. There's like 100. So that would take all day. So what I did was I grabbed, well, you can't see it on the screen. It's cutting it off. But I promise there's 650,000 hashes in this that I just grabbed randomly with a sort-r command. So I'm going to show you all how you can crack a list like this with no word lists whatsoever, right? So I got plenty of word lists, and I'm good, except for what if you wanted to use this list against itself? And this is what I'm going to show you about patterns, is that when you have a password list, if you can crack some of the passwords, there's already patterns in there that you can look at and go after. So, all right, so in Hashcat, basically, like, I'll just go over it real quick. M is the mode, so that's the type of hash. So if you do Hashcat, hashcat.help, it will give you all of this. And so if anybody needs any help with it, I'm happy to, but I don't have a ton of time, so I'm gonna do this kind of fast. And then you have the, hash file, and then you do an output file. We'll just call it crack.txt. And then so what we're going to do initially is a brute force attack. Now remember I told you John was a little bit better about brute forcing attacks, except for in this situation it's going to work really well for us. What we're going to do is an A3 is the attack mode of brute force. So there's 7 attack modes. I'll try and hit them all. And then we're going to do, remember the -A? The other thing that we're going to do is a -I for incremental mode. So that's going to start at 1. And then go up to however many A's we give it here, right? So we're going to give it 6 A's for the sake of time, but we would probably do 7 if this was in the real world. 8 can kind of take a long time, but so hopefully this won't take too long. Let's see. So if you look here, you can see there's a couple of pieces of information that it gives you. It shows you the mask that you're running, so -A, or question mark A. It shows you the number of characters, which is 4. And then down here, it shows you how many hashes have been recovered out of how many. So, you can see that back in 2012, LinkedIn had a really crappy password policy, and that 6-character password still worked, and that they didn't have any type of, complexity on them. So you can see with just that brute force attack, we've compromised 123,078 of our passwords that we're looking at so far. The reason that this number is so much less than 650,000 is because there were duplicates in there. So it automatically removes all of the duplicates. Okay, so now we got that list. So here's our, uh-oh. I don't know why that didn't make an output file. Hold on. I'll have to do that again. Yes. There were no salts in these SHA-1s or anything like that. So, hold on. For some reason it didn't make the output file, and I'm not really sure why. It just takes a second, though.
up the ultra rate on this one? How long until if you're running the standard I5 desktop, you guys think?
I mean, it just depends if you're using the CPU. I mean, so I'm using the GPU version of Hashcat here. There is a CPU version, and I do all the time on pen tests, like before I SSH out of an organization, like I always try to run it against whatever word lists I got locally or whatever. But I mean, I'll try for, I'm pretty impatient, but I'll try for, 30 minutes or something, or let something run in the background while I'm catching some NBNS hashes or something like that. Did that work? So for some reason, it's not making the output file. I've never had that happen before. I'll be mad if the first thing in my demo doesn't work. So also, I didn't go over, there's a -- remove command, and that actually removes the hashes that you cracked from the list already. All right. Well, that's not working for whatever reason, but we're still going to keep doing it. So I don't know why, but so we'll try it with a wordless attack instead of the brute force. But I'll show you the same thing. But so basically, like the wordless attack is the default, and then so you literally just do the same thing, but you give it a pass to a word list. And I'll let that run while we go over some more slides, because I knew it wasn't going to work. All right, we'll let that run for a second, and I'll still show you what I'm going to do with we'll just pretend like it was a brute force list. I don't understand what's wrong. I feel like I have something in my command wrong, but well, I guess I'm just going to talk about them. Sorry. We'll go back to that in a second. All right. So what I was going to show you is that what's really cool about Hashcat is this particular attack right here. So this gets me through almost every single pen test, which is called the combinator attack. So basically what happens is in Hashcat, you can put a dictionary on the left side or the right side, and what it does is it combines the two dictionaries together. So what I was trying to show you is that if you take a list and you brute force, the lowest number of passwords in there possible, you'll get like a little bitty list, and you'll put it through this tool called the expander. I'll at least show you the expander, And then what you do is you make the dictionaries on two sides, and what it does is it takes all the patterns that you found in the organization and puts them together and makes bigger patterns. And I'm going to get it working in a second. Hold on, because it makes me mad. But anyway, what happens is that if you have like password, say you had these 4 words in your dictionary, password 1, 2, 3, 4, 5, oh my god, and test, you would get pass 1, 2, 3, 4, 5, pass, oh my god, pass test, like so on and so forth. And so, let me just see if I can do that with somewhat orderless. Maybe my internet's dying. It can. I just did it. Like, I swear I've just been out there doing it like the whole time because I was so worried it wasn't going to work. I'll try one more time. I actually know. Let's see. But see, now the problem is I removed all the lists. Let me see. Maybe it went somewhere else. Nope. Yay. So anyway, what I was going to show you is you get like a little bitty list, and if you use, there's another tool called Hashcat Utilities, and so like, I guess the internet's just not working in here. I don't know. It's having a problem. There. So so then what we do is we get a list going, and we use this tool called the expander bin, and I'll just show you like, so if you do like echo password and then you put it into the expander. So what we do is we take our lists. Oh, awesome. I guess my Wi-Fi works better out there than it does in here, so like, seem to be having an issue, but anyway, so alright, so this is what I was trying to show you. So like, so this is just one word, and what the expander does is that it cuts up. You can't even see it. What if I do this? Okay. So what it does is it cuts up the word and it makes all these different combinations of the word. So basically what happens is you take one word and you turn it into 50 different words. And then so if you took like so if you build a dictionary, let's look and see what I got in my pop file here. So Hashcat also uses a pop file if you're used to using those with. Okay, so we'll use that. So stop. Yay. So we'll use this for our file since we got all these correct passwords in the All right, so let's just pretend that was our dictionary. Maybe there's more in there than I thought. So this only works with smaller dictionaries, so if it's really big, like it takes too long. Okay, that's more like it. Okay, so let me move this over so you can see, I guess. All right, so here's our dictionary file that I made. It's got 107,781 passwords in there. So what I'm going to do is I'm going to run that through the expander that we just talked about. And then we're going to sort them by unique so we don't get too many. And we're going to put that in what we're going to call out working2.text. Right? So those were all the passwords from whatever brute forces I just did with LinkedIn. I just don't know. It's supposed to write to a file, and I don't know why it wasn't working, but I'm not going to sit up here all day and like debug it. But so we'll let this run with the expander. It shouldn't take that long. But anyway, while that runs, we'll move on and talk about the other kinds of attacks. So a hybrid attack is going to be just like, so the combination attack had a dictionary on each side, and it puts the words together. The thing about a hybrid attack can go either way. You can either append or prepend digits to the end of the word. So if you do a dash or attack mode 6, it actually puts the so basically what you have is a word list on one side, and then you have the brute force characters on the other side, and so you can append whatever you want to the dictionary word, or you can prepend based on which attack mode that you take. So that's really effective for like downloading a list, and then say you want to put 2016 at the end of every single word in the list, you would run that. Let's see if this is done yet. Okay, so now if I check how many passwords I have in working2, like this, you can see that like I've got a whole lot more. So I started out with 107,000, and now I have 371,000. So now what I would do with this, 100 because we got SHA-1 hashes. And so here's our list that we have left, and then we'll try this fucking output file thing again. And then, so that's attack mode 1. And so basically what we're going to do is we're going to do our working2 list twice, like this. And so what it's going to do is it's going to try to put all those together. And so this is hit or miss, but it's really effective like almost every time. So I didn't plan any of this out. I'm sort of YOLOing it on the fly, so hopefully this will actually give us some hashes. But then, hold on. We want to actually watch, oh wait. So you can see from our status that with those two dictionaries, we've recovered like a whole bunch of passwords that way, right? It already finished, but I meant to, but like, let's go look at some of them and see how difficult they were. Oh, so now it decided to work. That's pretty awesome. So anyway, you can see that we've got some alright passwords, right? None of these are particularly awesome. They're 8-character passwords, right? But we're better, right? Remember we started out with brute forcing 6-character passwords, and then we put those together, and now we got some 8-character passwords. So what if we did it again, right? So what if we did, are you serious? Okay, so what if we did our crack.txt, right? But we have to grab just the passwords out of there. 2, and then what if we sent those back into our expander again? Sorry, I can't see. Then we want to sort those uniques, and then we'll turn that into working3. So I'll let that go for a second. All right, so let's see how many we got in the working3. And then, so we're going to do that same attack again, except we're going to change it to our new list that we've got. So basically, you can do this over and over and over again, like rinse, lather, repeat. Like I've had it go up to 20, 25 iterations of this, and you'll keep getting passwords every time because the passwords will keep getting bigger and bigger and bigger. And so by, the 9th, 10th, 11th time, you'll start cracking like ridiculously long passwords. Like, let's see if we can get anything good. Like I said, I didn't plan this out at all. I just grabbed some hashes out of there. I don't know, it's not getting any more that way. It's having trouble writing to the file for some reason. But anyway, the difference between the hybrid attack is that you would, so it's either A6 or A7. So if there's an A6, you would do the working text and then you would do, remember our variables, so you would do A. Like say you wanted to do 2 digits at the end, you would just do it like that. That's really effective too. It's like stuck because it keeps saying it doesn't remove them. Oh, maybe that's the problem. Hold on. So anyway, I knew it wouldn't work, but at least I can show you the different attack modes and how to do it. And then 7 would be the opposite. I don't know, this thing is broken. I should have rebooted it. But anyway, the other thing that Hashcat has is rules, much like John, if anybody's used to doing the Hashcat rules. So going through all of those is like a little bit difficult, but they're all in this file right here. So you can see that there's all these different kinds. Well, if I move this over, you can see. So, some of my favorite rules, the best 64 is like, whatever we think are the best 64 rules at the time, like that changes. Dead One is a friend of ours that was on our Hashcat team that's no longer with us. He wrote this rule, and so basically like the rule files are almost all done for you. I can't even think of a rule that's not included in here at some point. However, you can look in these and they're really easy to write rules, and I'll show you the table in a minute. But so basically it's like one rule per line, right? And you just make the rule do whatever you want to. And so we have some tables. These are all on the Hashcat wiki. I know you can't really see this, so you're just going to have to take my word for it. But it basically says, it tells you what the character set is and what the rule does. And so if you wanted to make a rule file for an organization, you can do that. And there's also a tool that will take a word list and make a rule file for you. Here's some more examples of rule files that are in there. All right, so if all my demo would have worked, like we would have been doing really good at this point, and we would have cracked 50% of the passwords, but we didn't. So the next thing I want to show you is, say, a lot of times password cracking like this will only get you so far. Like it will only get you to like 50% of the passwords, and then you won't know what to do next. And so the most important part of this type of stuff is learning how to analyze the passwords. And so it can take a minute, so I did do one in advance. So this is a tool that's called PAC. And so this was written by a guy named iFelix. He wrote a couple of tools here. I probably don't have time to talk about them all. But the coolest one is the stats generator. And so basically what you do is you just run it against a word list, and it will give you the top 20 masks out of that word list. So remember how we talked about the masks? So what we're looking for is pattern-based passwords. So when you run this, and I think I ran this against the RockU word list, I believe, you can see that, that these are the masks that were the most popular in the list. So say you crack 50% of the passwords of an organization and you want to crack some more, you would run a tool like this against it, and then you would grab these masks out of here. So like, say you just wanted to use these. I mean, you can literally like copy and paste them, and then, I'm sorry, I'm having some internet problems. But you would just you can copy and paste these into a file and just get rid of all of this. You just want to have the masks one line per line, and then you call it a HC mask file, and then you literally, instead of the mask at the end of the line, you just give it an HC mask output. So Oh. I'm not having very good luck today. And so the thing to do is to keep a running list of like the most popular masks that, that you have, based on all of the lists. So every time like we get a new list, we'll run this against it and we'll keep like the top 20 masks. So like, pretty simple. You just grab them out of there however you want to. You can use whatever tool you want to. And then oh, oops. Make sure it worked. All right, so then you can run, just go up and find another one. So you can run it the same way. Oh, yes, they do. Let me do that again. Hold on. Of course. So let's see. Pretty sure that's right. Oh. Okay. Okay. Thank you. That would have probably taken me forever to figure out what was wrong there. All right, so just how to use a mask file real quick. The point that I wanted to make with the talk is how important these mask files are. And so analyzing every password list that you get and every time you do a pen test on an organization and you dump the Active Directory database, running this on there and making sure that you have an adequate, password mask on there. So you just do A3 and then you would do the name of the mask and then you would run it like that. And you would do all of these top masks on there. So I guess I'm running out of time a little bit, but I'll just go over. There's a couple other tools for analyzing. DigiNinja wrote a really cool tool called People that gets the masks out of there. But some other stuff that it does is it pulls the root words out. When we talk about root words, we mean taking away all the special characters and just doing the words. So that tool is really valuable. Here's the pack tool. If you're into downloading it, it's at thesprawl.org. There's a couple other tools in there, like real quick. There's the stats generator. That's the one that we just talked about. It basically gets all the statistics from a list, but you can also do a mask generator. So that's taking a list and it generates a file of masks for you based on how much time you want to use to crack it. There's a policy generator where you can actually put the password policy of the organization in there, and then it will build you a mask file based on that policy. And then there's also a rule generator where you can give it a bunch of rules. There's the Hashcat utilities, which is where we got that expander.bin. There's a bunch of other tools in there that you can use for analysis. There's some other stuff, the mask processor. These are all tools to generate mask lists for your password attacks. All right. So I guess I'm out of time. Sorry my demo didn't work very good. So thanks, everybody.